Sweet. Hey, everybody. Welcome back. Today we're talking about protos and prototypes and all things mystical about JavaScript inheritance. Justin won't be leading this today. He had to step out. But with me, I'm Alexis, the main trainer. And then with me is my colleague from Bitovi, Joe Crick, who will be joining us. For those in the Gitter chat that were attending last week's session, we're going to go through quickly our answer keys from last week. So if you're not in the Gitter chat and you're just watching the podcast, check us out. We're at bitovi/js-training, and there's a link in there for the JS bin where you can stream in and watch the answer keys from last week's exercise. So last week we were talking about context, specifically what is this in a function, very different from a statically typed language. But we give you a couple exercises, dot and dot call, rewriting JavaScript operators with JavaScript itself to kind of understand how things are flowing. So the dot exercise, we said, hey, if you had a dot function and you accepted an object, let me share my screen with you too, for those that aren't on the JS bin. There we go. Does that work for you, Joe?
Yeah, I see it.
Cool. So we had an exercise for the dot operator saying, hey, if you had dot as a function that accepts an object and a property, you'd be able to walk up the proto chain until you find that property and then return it. We give a few hints. We said the first thing you want to do is be able to check if my current object, where I am currently on the proto chain, has that property. If it does, return it. You can do that with has own property. So the first thing we do is say, if my object has own property prop, go ahead and return that. Let me go ahead and run these tests right now. I should see a bunch of failures. Otherwise, we want to keep walking up. And this is the trick, because a proto is just going to point to another object that may or may not have the property. And you want to walk up its proto until you get all the way back to base object, until that proto points to null. So we need some kind of iterative mechanism. You can do this with a while loop. That is an option. As Justin mentioned last week, our preferred method is recursion. And to understand recursion, first, you must understand recursion. So what I'm going to do is I'm going to recall our dot method, but I'm going to pass in object.proto. And we're going to look for the same property on its proto. Now, if this proto does not have it, it's going to fail this next if condition and come down and do it again with its proto. So the proto. So it's going to keep walking up until we get nothing. We should get, we want to say, now that we've walked, you see this died on test number 2, cannot read property of has own property of null. So at this point, the test is walking all the way up and checking for something that's undefined. So we need an additional check right here to say, hey, we don't want to just say if we have the property, we want to make sure we exist. If object exists and object has own property, then return it. Actually, we could put that, this should be okay. Oops. We want to check if our current object is null, we can has own property, but we still want to make sure we're not going to recurse if, actually that should be okay. Did I do something wrong there, Joe? Let's see.
It doesn't have the object.
Can't read property of null. Yeah, that makes sense.
Yeah.
So if object, so we can do this.
That's right.
There we go. The only case we want to check, otherwise it's just going to return undefined. So if it's null, both conditions will fail and we return undefined. This is going to cover all of our use cases for the dot specifically. Does that make sense? Let me know if it doesn't make sense. Joe's got an eye on our Gitter chat, and we can go through any kind of different scenarios for us. The second exercise was .call. Now, call is kind of confusing in our terms when we're talking about this. Call refers to the open and close parentheses, the invocation of a function. This is a little confusing in JavaScript because there's actually a call method when we're talking about these kind of like really deep internals. But for this purpose, we're talking about invoking a method on an object. What this is going to need to do, it needs to walk up the protochain to find a handle to whatever method we want to invoke it with the context of our object. In this case, person.speak. Speak could be on something on human's prototype, if person inherits from human. And even though it's all the way up the protochain, when we invoke it, this inside of the speak function will point to person. So this was our hint last time here. The first thing we need to do is we need to find a handle to the function we're looking for. So Joe, can you think of any way where we could walk the protochain to find that function?
Any way we can walk the protochain to find that function.
Because if we think about, we don't
Well,
want
yeah, I mean, go ahead.
Yeah, we don't want to invoke this function first. We just want to find a handle to it. So right now we're looking for like person.speak without the open close parens.
Well, I mean, we can make a call to dot.
We could totally do that. So it turns out we just wrote a function that can do exactly what we need here. So we can say dot obj prop. And this will give us a handle to the function we're actually looking for. It walked up the protochain, found the correct function, and now we have a handle to it. Now to invoke it, if you remember, there's 3 ways to set context on a method. One is the dot operator, which what we're doing here. 2 is the new keyword, and the 3rd is call and apply. Remember, call and apply do the same thing. All they do is invoke a method with a context that you specify. So the first argument is going to be the context we specify, and the second argument for apply will be an array of arguments. So here we can say f and apply, and the context we want is obj. So if we say person.speak, it's going to look for the speak method and invoke it with person. The second argument is an array of what arguments need to be passed into speak, and we have it right here. This is our signature. They're giving us an array, so all we have to do is pass args. And if I run this, now we're all green. Cool. Any questions? Joe, is anything going on in the chat? Let me flip over there real quick.
No.
I think we're good. Cool.
We're good.
So that's last week's. Let's talk about this week's. So, oh, I didn't realize it was animated like that. Welcome back. This is session number 6, I believe. We're going to talk about all things proto and prototypes. If you've ever seen .__proto _ and .prototype and wondered what they were, or if you've heard the term prototype-based inheritance, we're going to go over a lot of that here in a second. So one of the biggest misunderstood concepts in JavaScript is how we simulate this kind of inheritance pattern that we're used to in classical languages. In a class-based language, you typically have a syntax for inheriting. So you could say, if it's Java, you could say like public class, person, human or animal. And this is, the language is giving us a way to express when one object inherits from another object, or one class inherits from another class. In JavaScript, it's actually a little bit simpler, but fundamentally different. So we have what we refer to as the proto chain. As we talked about last week, if a method or a property is looked for, if you're looking for a method or property on an object, it's going to keep walking up this proto property until it finds it. With this kind of knowledge, we can set up, we can manipulate what is on that proto chain and put methods or properties higher on that can be reused later. So let's talk about a quick example here. Here we have animal, which is our constructor function. You can create new animals off of this. And inside that constructor function, we're going to set an offspring property. By default, it'll be an empty array. We assume that animals can have offspring later on in life. And then we'll move on. We have a dog, which is just an empty constructor. So you can create new dogs as we do down below. And this is a really interesting third line here. We're going to say dog.prototype equals new animal. This might look a little weird. If you're familiar with JavaScript, you might have seen this before. Maybe you're not sure what it means yet. We're going to get really deep into this. And then we're going to create 3 dogs, dog 1 and dog 2 and pup. These are all new dogs we've created. Dog 1 will have, because it's a dog and a dog is an animal, dogs have offspring. So we're going to say dog1.offspring push pup. Joe, what do you think dog2.offspring will return?
Dog2.offspring is going to return a blank array.
That's what you might think. Dog1 and dog2 and pup are 3 new instances of dogs. Dog1 has some offspring, but dog2, I would expect that to be just an empty array if we're thinking about how dogs propagate. But in this case, it's actually going to be pup, which might be a little weird. That might be a little bit strange just looking at this face value, but we have a handy way to kind of draw this out. So we're going to come back to this. Let's talk about what it means to be on the prototype. We saw that dog.prototype equals new animal. What does any of this mean? So let's take our simple constructor. We have animal equals function. It takes an argument, a name, so you can name the animal. And we're going to say this.name equals name. We can attach a method to the prototype. So we're going to say animal.prototype.eats. A handy way to remember a little trick about protos and prototypes. Objects will have protos. Functions will have prototypes. So animal is a function in our case, but we can say animal.prototype.eats is going to be this generic reusable function. In our case, it's just going to say this.name is eating. It's going to return a string. What this is doing is here. Animal is just a pointer to a function in memory, which has a prototype property. Whether or not you declare animal.prototype, it's going to be there implicitly. It's going to point to an object. In our case, we have an eats pointer pointing to another function in memory attached to that object. I know that was a bit of a mouthful. Let me relate this if you're familiar with static or classical languages, such as Java and C#, and a little bit more of those kinds of terms. In Java and C#, we really aren't focused on too much other than the class. The class is the definition. It's the blueprint, if you will, of all objects that are about to be created. So if you have a person class and you say new person, you really put a lot of emphasis on the definition of the class. In JavaScript, the blueprint is, you can kind of think of the blueprint as the prototype. The difference is, in Java, the class is explicit. You have to write the class. In JavaScript, the prototype is implicit. As long as you write a function, there will be a prototype, even if you didn't type the word prototype in your code. So you always have, if you have animal equals function, that function will have a prototype. That prototype will point to an object. And then we can attach things to this object. Why is this important? Well, when you use the new keyword, here in our case, we're going to create a new animal. It's going to be Sponge, and his name will be Bob. Sponge equals new animal Bob. What this is doing, what the new keyword is doing for us, is it's creating a new object in memory, then it's pointing its proto property to the prototype of our constructor. I know that's a long-winded way to say it, but it's once you understand this concept, it's really, really powerful with what you can do. So we've created a new object in memory, and if you remember, objects have protos, functions have prototypes. This object's proto, because we used new, will point to the animal prototype. Why is this useful at all? Well, oh, and let me get to the constructor here in a second. Why is this useful? Because remember, in context, when you're looking for a property or a method, it's going to walk up the proto chain. So if you wanted to say sponge.eats, it's going to look on sponge. It's going to say, you don't have an eats property or method. And it's going to walk up the proto to the animal prototype. And it's going to say, do you have an eats method? And it does. And it will return that eats method, which is kind of cool. If we can point the proto where we want, we can stash methods and properties in higher places to conserve memory. In this case, if you wanted to create 1,000 animals, you would still just have one eats method, but they all have access to it. The last thing, not the last thing, but one of the things the new keyword will also do for us is it's going to invoke the constructor. We're saying new animal and then open close parens. We're calling a method. It's going to invoke our animal function, but this, inside of that function, is going to point to sponge. So when it runs, when it says this.name equals name, this will be sponge. It'll say sponge.name equals Bob, because that's the argument we've passed in. So a really quick review of everything that just happened in this graph. The new keyword is going to create a new object in memory. It's going to point the proto property of that object to the prototype of our constructor. It's going to run or invoke the constructor with our new object as context. And then the kind of the unsaid thing in this little section, it's going to return that new object and assign it to the left side. So there will be a pointer, sponge. This should actually have like sponge as a pointer pointing to this circle if this graph was 100% accurate. And return that object. Cool. So let's take a simple inheritance paradigm. We have mammals, chordates, and animals. The difference between the three: mammals are chordates that have hair, chordates are animals that have spines, and animals are any organism that eats other organisms. For our definition, if there's any biologists, please don't hold me too true to these diagrams. In JavaScript, if we wanted to set up this type of inheritance structure, we're going to have three functions. You're going to have a mammal function, and a chordate function, and an animal function. These are all constructors, so you can create new animals, new chordates, and new mammals. Because they're functions in JavaScript, implicitly they will have prototypes, and these prototypes are objects. So you're going to have an animal prototype, a chordate prototype, and a mammal prototype. If we want one to inherit from the other, what we need to do is point their proto properties of those objects to each other. Mammals prototypes proto property will point to chordates prototype, and so on and so forth up the chain. How do we do this in code? Here we go. Here's a simple animal function. It's the same constructor as we had with SpongeBob. And we're giving it an eats function on its prototype. We're not doing anything special here. We just have a function. We know functions have prototypes, and we're going to attach a pointer, eats, which points to another prototype. To another function, I'm sorry. Then we're going to create a chordate constructor in memory. So we have chordate, it has a prototype, and it has a prototype pointer, which points to this object in memory. Now, just sitting alone, just creating a chordate constructor, this doesn't inherit. this doesn't have a proto chain set up to go through animal just yet. Right now, this all goes through base object. If we want to point that pointer from coordinates prototype to animals prototype, we can say coordinate.prototype equals new animal. With our knowledge of the new keyword, we're going to create a new object in memory with its proto property pointed to the prototype of its constructor. So we're going to create an object with its proto property pointed at animal prototype. Then we are assigning it to coordinate.prototype. So coordinate.prototype is now pointed at that new object we've created in memory. With this concept, we've now linked the two on our proto chain. Then we give it its own methods or properties. In this case, it's just a Boolean that says, hey, these all have a spine. And we do this one more time again for mammal. Mammal constructor on its own will just be a function with a prototype pointer pointed to this object in memory. But by saying mammal.prototype equals new coordinate, we've created a new object in memory with its proto property pointed to coordinates prototype in this case. Now we've set up a chain all the way from mammal to animal. So, and we'll want to give, if we want to give any arbitrary methods or properties to mammal's prototype, we can do that here. But this gives us the ability to create new mammals. So we can say m equals new mammal dog. Again, the new keyword creates a new object in memory. Its proto points to the prototype of its constructor. But if you wanted to say m.eats, m.has spine, or m.has hair, these will all return true or invoke a function no matter where it is on this proto chain, now that we've linked this up. Cool. Okay, now you may have noticed there's one kind of glaring flaw in this. In the constructors, we're repeating ourselves. Animal equals function name, this.name equals name. Coordinate equals function name, this.name equals name. Same thing for mammal. This is kind of unnecessary, a little bit verbose. In classical languages, you can typically just invoke super to invoke your parent's constructor. But again, because we don't have this kind of functionality, we don't have classes and this concept of it, we need to do something a little different. What we can do, if we wanted to rewrite this, here is our animal function and prototype. And this is okay because it's the base kind of level we're looking at. But for coordinates, what we can do is we can say animal.call this and name. This is going to invoke the animal constructor with our context, with whatever a new coordinate is being used as. Now this may look a little bit more verbose if it's just this.name equals name in your constructor, but typically in your constructor, you probably have a little bit more logic going on, and this is one way to kind of reuse that logic. There's a lot of libraries out there that give you super kind of methods or plugins. CanJS is one of them. If you look internally to see what it's doing, we're doing stuff like this. We're taking a method and we're using call or apply to invoke that constructor with arguments and context that we specify. So if we step through this again down to mammal's function, we can see it's doing exactly the same thing. It's just going to call coordinates with its context and arguments. Same chain will be set up, but we don't have to rewrite any functionality. So if you would have a ton of functionality in animal, coordinate, and mammal can still reuse those functions.
Alexis, we have a question.
Shoot.
Zerk says, you said that you're setting proto, but using prototype?
I said that I'm setting proto, but using prototype. Well, what we're doing here, is this in reference to a specific section of the slides, or?
I'm wondering if it has, if you notice on the slide, it says proto between,
yes.
It makes that link, and then in the code, you're setting prototype. So I'm assuming that's the question I can ask and get
Oh, yeah. Let me go back. No, that's a good one. Here, let's go back to this kind of example. This probably says it better. So we're using prototype, but realize what is setting proto is, I don't know if you can see my mouse on this. Can you see my mouse?
I can.
Okay, perfect. I'm circling, can I highlight? Oh my God, I've never actually tried this. Pen? Look at that. I've never tried this in PowerPoint. What is actually setting the proto is the new keyword. This is the trick. So what we're doing here is we're creating a new object in memory with its proto pointed to the constructor, to the prototype of the constructor. Whoops, I wanted my pen back. This is our constructor, and animal.prototype is its prototype. So when you use the new keyword, it's creating a new object in memory, and it's setting the proto to whatever we want. In this case, it's the animal prototype.
So all that is done, in other words, behind the scenes. It's not
Exactly.
something that you would actually type out explicitly, whereas the prototype you would type out explicitly.
Exactly. So in our case, now you can do this for anything. It says, hey, I'm going to create a new object, and I'm going to set its proto to the constructor's prototype. And it's going to assign it with whatever is on the left side of that equation. So in our case, if I say coordinate.prototype equals new animal, what this is doing is it's creating, let's just talk about the right side first. I wish I could block out the left side. But if you say new animal, we've created a new object in memory with its proto pointed to animal prototype. And we're assigning it to coordinate prototype. This is why we're using prototype here. What is on the left is actually, in terms of setting the proto, what is on the left is irrelevant. We could just say sponge equals new animal, var foo equals new animal, and those will all be objects with its proto property pointed to animal's prototype. But with our concept of setting up this proto chain, we can say coordinates prototype is just an object, which will be its proto will be pointed to animal's prototype.
So there's another question.
Sure.
And John Hitz asks, so proto is just the link or pointer to the prototype?
Yes. A link that points to where do I find things. That's all proto really is. Objects have proto properties, so that if you look for a method or a property on an object and it's not there, it has somewhere else to look. So it'll walk up that proto to the next object and say, okay, do you have this method or property? And it's going to keep walking up protos until eventually it'll hit null, which is like after base object. It is exactly that. It's just a very simple mechanism to keep finding properties from some other object.
So there's another question from Zurich. He thinks his earlier question they believe is answered. The next question is, do we use proto in our code at all?
Do you use proto in your code at all? So typically you don't, and this is actually being, this one's a tricky question to answer. In the old days you did, because this was the only way where you would do like a super plugin. You would need to know how protos and prototypes work so you can look for certain methods or functions at different places. But a while back we have a method called get prototype of, I believe. How about I double check that? Mozilla.org, get prototype of. Yeah, get prototype of, I was right. Which will do the same thing. This will return the proto of it. But typically, you don't need to use __ proto in most cases. If you're building like a low-level utility library that provides simple class inheritance, so CanJS, we have can construct. or anything that uses like a simulated class-based inheritance system, you're probably going to see __ proto used in their code base. In your applications code base, if you're building, a rich web app, you typically won't need to use __ proto. You'll probably just want to use the new keyword in a lot of different scenarios, and have the knowledge that the new keyword is setting proto for you. So if I walked over to, let me go over to Chrome, and I'm going to pop open a console. If I said var animal equals function, and animal.prototype.eats is another function, and then if I said var coordinates equals function, and I'm going to link the two. So if we say coordinates.prototype is equal to new animal, finally, I'm not going to do mammal. I'm just going to say new coordinate, if I can spell correctly. Now, if I take a look inside what we got going on here, you can see our new instance of coordinate. This is C. We have our proto chain here that is able to walk all the way up to animals prototype, and here's our eats method. So if I were to say c.eats, it's already in the console. It returns undefined, but it exists, which is pretty awesome. So with our knowledge of just pointing proto with the new keyword, you notice I'm not using __ proto in any of this. All I used was the new keyword. We're able to link, set up our I don't want to say simulated inheritance, but set up our version of inheritance with prototypes. A long way to say you typically won't use __ proto in your applications. Good questions. Great questions so far. Cool. Okay, so coming back to our pup example, where we had dog1 equals new dog, dog2 equals new dog, and when we pushed an offspring, a new dog onto that offspring, let's take a look at what that is actually doing in memory. So, and this is kind of a problem too, right? This is what we refer to as shared properties. You have to be aware of this when you're putting things on the prototype. Animal is a function, and again, functions have prototypes. So right off the bat, we have this in memory. We have animal, which is a pointer pointing to this function in memory. That function has a prototype property pointed to an object in memory. And this is all we have in memory so far. Then we have dog, which is a function. So dog is a pointer pointing to a function in memory. That function has a prototype, which points to an object in memory. Then, if you remember this line, dog.prototype equals new animal, what this is doing to animal's prototype, it's invoking animal's constructor. So this is the first time we're going to go inside animal, and it's going to say this.offspring equals empty array.
Alexis, I'm going to just interrupt real quick. You went sort of blank on me for just a little bit there.
Oh, apologies. Yes, no, let me start over from this section. The Wi-Fi in the building cuts out. Thank you for letting me know. I would have kept going. Okay, so we're going back to the dog example. Animal is a function with a prototype as an object in memory. Dog is the same. Dog is just a function. Functions have prototypes. It's pointed to an object in memory. And dog.prototype equals new animal. This is that weird syntax we saw earlier. Dog.prototype is just pointing to an object in memory currently. New animal is going to create a new object in memory with its proto pointed to the prototype of our constructor. So proto is going to point to animal.prototype. And it's going to invoke the constructor. So this is going to say this dot offspring right here. This, because it's one of our 3 context rules, if you remember from last week, this can be set by the new keyword, and it's going to point to the new object being created. So this dot offspring will be our new object dot offspring, which will point to an array, which is also an object. And then finally, we're going to assign it to dog.prototype. So now that we've created this new object with a proto property set and an offspring property set, we are going to assign it to dog.prototype. This is our chain so far. And you might already be able to see where the problem is going to be when we start pushing things onto this offspring. So when we say dog1, dog2, and pup equals new dog, you're going to have dog1.proto is pointing to the dog prototype, dog2.proto is pointing to the dog prototype, and pup is doing the same. These were all new objects created with their protos pointed to the prototype of their constructor. So when we finally say dog1.offspring.push pup, let's walk this chain. Dog1.offspring. So dog1, do you have offspring? No. So let's walk up the proto chain. Oops, lost my mouse. Walk up the proto chain. Now we're on this object here. Do you have offspring? It does. So it's going to push pup onto this array, which is kind of weird. It doesn't make sense in the terms of actual dogs. But when you say dog2.offspring, the lookup is going to be the same array. Dog2, do you have offspring? No. It walks up the proto chain. Does this object have offspring? Yes. What is the array? It's the same array that dog1 had. So this is something you really want to be careful about. If you're putting properties on a prototype, those properties can be shared and modified. Let me rephrase. They will be shared and can be modified by any inherited instance. In this case, dog1, dog2, and pup will always all have the same offspring in this scenario. An easy way to correct this, I don't think I have a slide for this. Yeah. An easy way to correct this particular scenario would be inside dog's constructor to recall animal's constructor. So you could have the same code, this.offspring equals array, or animal.call this arguments. Those would both do the same thing. Though that would actually give dog1, dog2, and pup their own separate offspring arrays. Cool. Any questions on that? Still good, Joe?
Yep. I haven't seen any new questions. We're good.
Sweet. Okay. So prototype-based inheritance really is just understanding functions have prototypes, objects have protos, and the protos can be set using the new keyword. So just like last week, we have an exercise. We have a couple of exercises here. I'm going to go over this exercise and a little bit of walkthrough first. Then we have one more concept I want to tackle before we let everybody go, and then one more exercise. So just like we talked about dot and dot call, we're going to write the new operator as its own function. So here's an example. We have var person equals function. This is just a constructor, and it looks like it's going to set a name property on our new objects. And we're going to give it a prototype method. So we're going to say person.prototype.speak is going to be a function that just says hello. What we would like to do is write a function, new, which takes 2 arguments, the constructor we want to use and an array of arguments passed to that constructor. Var person equals new person, and then an array of strings in this case should be the same as var person equals new person with name as a string. These should be equivalent. Then when you invoke person.speak, we should see a console log hello. We really, oops.
So Alexis,
it'd be really nice if we said hello name. That'd probably be the better exercise. Yes, go ahead.
there was a request from John Hitz to back up a little bit, and he wanted to see in the terminal not using a different this for each dog1, dog2, and pup.
Using a different this?
Mm-hmm.
Oh, you mean actually setting, so fixing this example, basically?
I'll confirm.
So if we said our animal is equal to a function, we're going to say this.offspring equals an array. Our dog is equal to a function, and I'm going to say animal.call this. No arguments. Should be okay. And then we're going to say dog.prototype is equal to new animal. And that's all we have, right? And then we have dog1, dog2, and pup. Okay. We'll say dog1 equals new dog. Dog2 equals new dog. If I say dog1.push, well, let me create pup as well. Let's make it exact. Pup equals new dog. So if I say dog1.push, oops, dog1.offspring.push pup. Now, if I say dog1.offspring, we should have there's our dog.
Is there a way you could make that console a little bit bigger if some people are having trouble?
Totally.
Yeah, thank you.
I don't know why it's not. There we go.
Oh, I guess a little bigger for me.
Yeah, I was trying to scroll it up. Here, let me.
Sure.
Oh, it won't let me. You know what? Let me pop this to the side. There we go. I hate when it gets too close to the bottom. So this is the corrected version. You can see dog is not just an empty constructor. I'm actually basically calling its super constructor. I'm saying, hey, re-invoke the animal constructor. And what that does is fixes our shared property problem. Whenever you create a new dog, these dog1, dog2, and pup instances will all have their own offspring arrays. So now I'm doing the same thing, dog1.offspring.push pup. Here's dog1.offspring. It's an array with pup inside of it. Dog2.offspring is empty in this case. We have a fixed kind of scenario because now each dog has its own offspring array. Did that make sense? If that didn't answer your question, I do have a whiteboard behind me. It's a little hard to see, but I could draw this out too. Let me know if you'd like that drawn out. I'll step back into it. Okay. Oh yeah, sorry. Sorry for the font size. Cool. Okay. So let's step into this new keyword exercise actually. I believe I put it on the blog post from last week. It was a little bit of a preview. Get rid of that console. Context. We should have next week's exercises. Sweet. So here is, yeah. Drop this in the chat here. You guys can stream along or make your own edits. Here is a ton of hints for the new keyword. This is a little bit more in-depth. You can see the same example we have from the slides, but we can talk about what the new keyword actually does. So remember, the new keyword does some really, really big important things. I'm gonna put them in comments in here, and then you guys can figure out the JS bins.
Can you make that font a little bit bigger too?
Well, I actually put a link in the stream, so everyone can actually stream along with this.
Okay.
I can make this a little bit bigger.
Just for
so the
people to
first,
watch.
yeah, the first thing, well, you can stream in JS bin, so that you can actually, if you click the link, you can actually watch as I'm typing,
Cool.
which is pretty cool.
Cool.
So the new keyword is going to do a few important things for us. One, it's going to create a new object. And this is kind of cheating. You don't do the new keyword exercise by using the new keyword in the exercise. That would be one easy way, but this is kind of academic. So if you remember, there's a couple ways to create a new object. One of the ways is to say like new objects, but a shorthand way is just to say open close brackets. So the first thing we do is we create a new object. The second thing the new keyword does is it sets the proto to the prototype of our constructor. So we're going to set proto of our object to the prototype of the constructor. Remember in our dog diagram, that was one of the first things the new keyword does for us. It creates a new object in memory and sets the proto to point to the correct place. The third thing it does is it's going to invoke the constructor. So it's actually going to call, if you remember dog in our example, invoked animals constructor. I'm sorry, if you create a new dog, it's going to invoke dog's constructor. So we can say call constructor, not just invoke it. We don't want to just say animal open close parens. You want to invoke it with obj, our new object, with our object as the context. So we're kind of digging a little bit into last week's series. If this is the first week you're joining us in this series, definitely go back. These lectures are meant to be kind of a compounded knowledge gathering. So check out last week's, because this week's is very closely tied when we're talking about context. So we want to invoke our constructor with context. And then finally, return our new object. These are the four big things the new keyword is going to do for us. Create a new object in memory, set the proto of that object to the prototype of our constructor, invoke the constructor with context of our new object, and then return our new object. We're going to give it back to whoever called our method so they can assign it to some variable or something else. Cool. Let me know if you have any questions on this. Myself, Justin, and a few other Bitovians are always in the JS training chat, so we can even help you out during the week. But this is the big things that this needs to do. Okay. So, in summary of talking about new and how proto is set and prototypes are used, we have our dog constructor function, which looks like this in memory. Dog is a pointer to a function in memory, and it has a prototype property pointed to an object in memory. This is with that one line of code. If you say pup equals new dog, the new keyword is creating a new object in memory with its proto property pointed to the prototype of our constructor, and it's going to invoke the constructor with our new object with pup as the context. Cool. I do want to talk a little bit about Object.create. If any of you have seen this before, this is another way to kind of set proto. It might be a little bit easier to kind of grasp, because we're not going to be, it's a little bit easier than talking about the new keyword, but let's talk about what it is. So I'm going to write animal as an object instead of a function. Animal in this case is an object, and I'm going to give it an init function and an eats function. These are arbitrary functions. The reason I'm doing it this way is to kind of keep parity with the other animal example we did earlier. And this is what it's going to create in memory. We have animal as an object in memory with init and eats. That's all that's going on so far. But if I want to inherit from animal, I can say coordinate equals Object.create. Then the first argument will be an object that you want to inherit from. The second will be an object with all the properties that you want to attach to the new object. So in this case, coordinate equals Object.create. It's going to create a new object in memory with a has_spine property, and it's going to set the proto to whatever the first argument was. So we have coordinate as a new object. Its proto is pointed to animal, which is another object. Same thing for mammal. We'll say Object.create coordinate, and this one has hair. And then finally, when you say M, I thought it was going to be SpongeBob. I was kind of disappointed. But if it's M equals Object.create mammal, we can say M is going to have its own proto pointing to mammal. And if I call init, which is our kind of pseudo constructor, because these are just objects, it's going to say this.name equals name, but this will be M because of the dot call. Now you may notice this diagram looks there's way less ink going on this page than there was in our proto and prototype examples, right, when we're using the new keyword. This will actually result in a lower footprint in memory. However, it is much more expensive, magnitudes more expensive than using the new keyword directly. I don't fully understand why it's so much more expensive, but I do know that internally in Object.create, they call the new functionality as well, amongst other things. Someone much wiser than myself explained it once, and I do not recall.
There's a question when you have a question.
Yes, go ahead.
The question is, the proto points back because of the new keyword wanting to confirm.
The proto points to the prototype of the constructor because of the new keyword, yes. New will set the proto of the returned object. Good question, really good questions. Object.create will also set the proto of the object. So there's now you have two ways to set the proto of an object without actually saying something.proto, something.__proto equals. You can use the new keyword, or you can use Object.create. Please use the new keyword. It's much, much faster, at least at the moment. So, as very popular with any kind of inheritance concept, you want to know what you're inheriting from. Am I a mammal? Am I a chordate? What is M? What do I have access to? So this is where you have things like type of and instance of. Instance of, if you're unfamiliar with the keyword, is a way to check if your object, its proto, is pointed to some other constructor. So if I were to step out into the console really quickly, Bitovi.com, open up a console here. If I were to say var a equals a new array, this is just array syntax. I could say array, like if I wanted to be really, really verbose. Here's a instance of array will return true because A inherits from array's prototype. This object's proto should be the same. If I wanted to say var d equals new date, a new date object. D instance of array will be false because D's proto is not pointing to array's prototype. This is what Instanceof is doing behind the scenes. It's walking up the proto chain to say, hey, is array somewhere on this proto chain? Is array's prototype somewhere on this proto chain, I should say. So going back to our exercise, we're going to create a method called Instanceof. It will take an object that we've created and a constructor that we want to compare against. So in this case, we have person as a constructor, and we're creating a new person, and we want to check, hey, is the person we've created an instance of person? Now, this should return true. This returns true or false. In this case, in our example, it should return true. But what Instanceof is going to do is it's going to walk up to each proto object to say, hey, is your constructor what I expect? Is your constructor person? And this could be many levels up on the proto chain. If you have, in our case with mammals and animals, I'll go back to that slide. In our case here with, there we go, mammals and animals, M is an instance of animal, it's an instance of chordate, and it's an instance of mammal. These are all true because Instanceof will walk up the proto chain and check each constructor to see if that is what we expect. Does that make sense to everybody? Let me know if it doesn't. Add a few more hints into our JS bin. So here we want to walk up in the middle of the screen. We want to walk up OBJ's proto chain until the prototype of our constructor found. I don't want to put too much pseudocode in. I feel like I'm giving away the answer a little bit. But this is what Instanceof is doing for us. Those are our two exercises for this week. But, oh, good timing too. But me and Joe can stick around for the next, let's say, 5-10 minutes. If you have any questions on the exercises or anything JavaScript related, I'll put back on my camera. Stop. Anything JavaScript related, me and Joe are here to talk about all things. So feel free and hit us. I'll put a blog post up with this week's exercises and next week's exercises. I believe next week is, actually I'm not sure off the top of my head what is next week's, but I will put that all up with our slides later today. If there are no questions, me and Joe can sit around and talk to each other, and you guys can join in. I know Justin he would not stop talking about Bloodborne, the video game last week, and that's all I've been thinking about ever since. So I guess I'm going to have to go pick that up. I don't know.
Check it out.
Maybe. Maybe.
Cool.
No questions?
I'm not seeing anything.
Trying to think of any big events coming up. I know Matt and Adam had a really good conference last week. I believe Tom is speaking at the Midwest UX conference. I believe that's coming up. I don't think that's passed yet. So if you're in the Missouri or Midwest area, I believe it's in St. Louis. So if you're in, even as far as Chicago, I would go check out Tom's talk. It's pretty cool. I don't think of any other big events. Go to your local JS meetups. A lot of Bitovians will be speaking at quite a few. I just spoke at Calgary's last week, which was pretty cool. Oh, that is actually out. There's a YouTube video of some. I'll find out where that is. I'll put that somewhere in the chat, maybe. Yeah, question. Go for it.
It comes and says, I'm a bit behind in my JS skills. That is, I'm probably not intermediate. Do you have any suggestions for background reading I can use to get caught up?
Totally. First off, start out. We're only at number 6 in this video series. Go back to number 1. It's all on YouTube. These are the primary core competencies that we look for in really good JS developers. So definitely go through the series with us, which is awesome. If you're looking for reading, the definitive guide is required reading, I think, for pretty much everybody. JavaScript: The Good Parts by Crockford, and one of my favorites, Secrets of the JavaScript Ninja by John Ressig, which basically covers these same concepts. I think the 3 most difficult concepts when you're getting into JavaScript, specifically from like a classical background, are context, this keyword, prototype-based inheritance, and closure scope. If you can lock down those 3 concepts, you'll have a pretty good head on things. I'm trying to think of any other literature offhand.
The JavaScript Garden is really good as well.
Oh, okay.
I'll post a link to that.
If you're a designer that's joining us learning about JavaScript, Tom has a book out. I believe it's just coming out. It's UX Design Decisions, I believe. I forget the name of it. But it's with O'Reilly. Look for Tom's book on there. That's pretty good. I feel bad because I didn't know the name of the book offhand.
Oh, yeah, Tom's book.
Yeah, no. What's funny is these are the core concepts for JavaScript, but JavaScript isn't taught in any form of like academia or anything like that. So really, for anybody that has these concepts take 2. Everybody has to make an effort to learn these kind of core concepts. So even if you're a beginner or advanced, I've met senior level developers that have always wondered, like, oh, that's something I was always unsure about, was where proto is set to a junior level developer or an entry level developer that's learning those concepts. So if you're just learning JavaScript and you have a comfortable conceptual understanding of prototype-based inheritance, that's a huge advantage in the industry. So hats off to you.
Prototypes in this keyword.
Yeah, context is huge. Context is very misunderstood because it's very different. It's actually a very simple mechanism in JavaScript, but it's fundamentally different than C# or Java. In C# or Java, you have a class, and this will always refer to the instance of the class. But in JavaScript, or in dynamic languages in general, well, let me go back. I'm going to say in JavaScript. I don't want to dig myself a hole there. In JavaScript, functions do not know where they live. They only know how they are invoked. This is how reflection, if you're in C# or Java, kind of works, is functions know where they live. This is also how you get like IntelliSense in your editors. If you ever wondered why there's not a good desktop editor with IntelliSense on JavaScript, it's because you don't know where the function lives. The ones that do have IntelliSense are typically doing like text-based recognition, where they're guessing what you're typing based on some other text in the file. Or if you're using a web-based IDE, those are constantly. You can even like right-click a method and say "go to definition of," because
another question
yeah.
too. It seems like this is directly related to proto and prototypes.
It seems like this is directly related to protos and prototypes. It's not directly related. It's just how the method was called. That's all it is. So if you have, let me share my screen. So if you have var, oops, we're missing a fav icon. If you have foo or person is equal to function, and you say this.name equals, let's pass in an argument, name. All we're doing is we have a simple constructor, and we're passing in an argument and saying this.name equals name. This is only going to be set depending on how we call this function. So if I said person and I just said Alexis, this will not be set. We didn't use any of our rules. So this will default to the window. So if I said window.name, there it is. We've set it on the window, which is probably not what you want. It's probably not what we would expect. 3 rules. There are only 3 rules for this being set in JavaScript. One is the dot call operator. So if I said var foo is equal to var function this dot name equals, I'm going to hard code it, Alexis. I said foo dot bar, this will be foo because we have the dot call. So this will be on this other side here. The new keyword, if I said var p equals new person, p.name will be set because we use the new keyword and we created a new object which is assigned to p. So p is this. That is the context we're setting. The third is call. So if I said var o is just an object, oops, let me get my mouse out of the way. Var o is an object. Throw all this stuff out. If I said person dot call o Alexis o dot name, we're manually setting the context. Here's our function. We're saying call this function with this context. So inside person, this will be o, and then this is the arguments that we're passing in. If none of those 3 rules are met, dot call, new, or call and apply, if those 3 rules aren't met, window will be the context.
There's a couple of questions related to this.
Okay.
I also note that I'm running up to the end of when I'm available, so I may need to drop off. There are 2 questions. One is, isn't this where the methods and data of a function live, similar to self in Python? And then the separate question saying, is this a placeholder?
Okay, hold on a second. Let me go through both of those questions.
Yeah,
so,
and I'm going to have to drop off at this point.
Oh, okay. Yeah, no. Thanks for joining us, Joe.
Yeah, my pleasure.
Not a problem.
Great.
Everybody give Joe a hand. I know it's online. Window is the default. So Madeline, this isn't a placeholder. It just lets you know it's the context of it. I mean, I guess I'm trying to think. I don't want to say it's a placeholder, but conceptually, you might be able to think of it that way. It's just how the method was invoked. Window is the default. So if a method is invoked in one of those ways, then this will be set to that context. Now you may not see it behind the scenes, especially if you're using different APIs like jQuery or something in that regard. This will probably be set for you. We definitely do that in CanJS, where you're creating new objects on the fly. We will set this for you to make things a little bit more like a typical object-oriented language, make things a little bit easier for you guys. The other question was, isn't this where methods and data of a function live, similar to self in Python? I can't relate to self in Python. Yeah, an abstract placeholder. You could think of it that way. It's not necessarily where methods and data of a function live, because you could have methods on a prototype. You could have methods anywhere and set this to what you want. So let me give you a really crazy fun example. I could say, how do I want to do this? I could say array.push dot call and then set it to some arbitrary context like O, which was just our object earlier. And I could push A, B, and C. This will be O. So if I look at O, now this is an object with 0, A, 1, B, 2, C. It has indexed properties and a length of 3. So in our case, this was manually set. It's not necessarily where methods or properties live, because push is something that lived on arrays prototype. And these properties are being set on O, which is this context that we've kind of passed in. If that makes, I don't know if that clears anything up for you, John. I'm curious about self in Python. Python, self. I'm not a Python developer, but let's take a look. Oh, okay, no, it looks like Python does have classes. Yeah, for instance attributes. No, this is not exactly the same thing. Not exactly the same thing. It's just what the context of the function call is. I should drink potfuls of coffee while, yeah. What's funny, Madeline, is I should drink potfuls of coffee when I'm trying to explain. Is it an instance of an object? Yes, John, if you're using the new keyword, the new object, the instance of the object is this. If you're using the new keyword, that is one of the ways this can be set. But if you're using .call, that could be just an object. Technically, an object, all objects are instances of an object. So even then, it's kind of true. Call and apply, however, can be whatever you want. This could be anything. It could be a string. It could be a function. I don't know why you would set it to those kinds of things, but for academic purposes, it's whatever is invoking it. That's the biggest, I think the biggest takeaway from the context training we did last week is functions only know how they are called. And that's how this is set. It depends completely on how the function was invoked. Let me flip on my camera. If that clears things up. Cool. If there's any more questions, I'll stick around in the chat. I need to get out because I've only booked this room for so long. But feel free, keep asking questions in the JS training chat. I'm going to be in there all week. And come back and join us for next week's session. I'm going to put up our slides, everything for this week in the blog. If you haven't been following it, it's blog.bitovi.com. Let me just put that in here. You can join us there and come back next week for some more JS fun. See you guys then.